Hey guys, today we're going to be looking at similar figures and their characteristics. Guys, similar figures are just the same shape but a different size. We've either gotten bigger or we've gotten smaller, and these are a result of dilations, which we've talked about before. So here we're given the information that figure ABCDEF is similar to figure LMNOPQ. And guys, this first thing that they told us has so many clues, because the order of the name matches the order of the second figure name. So they tell us what matches with what. So because A is the first letter, that means point A matches with point L. So I'm going to circle that. Point B corresponds to point M. I'm going to put a square around those. Point C corresponds to point N. Point D corresponds to point O. Point E corresponds to point P. And then point F corresponds to point Q. I'm going to put a little trapezoid around there. All right, so now that I've annotated on my shapes which vertices correspond with what, then this number 1 where it says name 3 pairs of corresponding angles becomes very simple, because corresponding just means in the same position in a similar shape. So point A corresponds to point L because they are in the same position of the shape. Keep in mind, it doesn't matter that it's rotated, because if we rotated them back to where they were in the same direction, point A would match with point L. So we're just going to label a couple. So angle A corresponds with angle L. Angle B corresponds with angle M. And angle C corresponds with angle N. So I would recommend that you pause this right now and write the remainder of the corresponding angles. All right, guys. So we know that angle D goes with angle O, angle E goes with angle P, and angle F goes with angle Q. So now we want to look at corresponding sides. So if I look at side FA, so side FA right here, the side that's going to correspond to that is going to be between the circle and the trapezoid vertices. So that is side QL. And the same if I say, okay, well, side CD, well, that would correspond with side NO. Notice it's not always going to be in what you think is the exact same spot, because shapes might be turned. They might be rotated. Right, and one final pair of corresponding sides, we can say that AB corresponds with LM. So again, at this time, I'm going to recommend that you pause this and go ahead and find the remainder of the corresponding sides. All right, guys, welcome back. So now we're going to look at the proportions, which again, guys, proportions, it's a big word, but all it means is equivalent ratios. So a ratio that's equal to another ratio. And we want to show which one of these prove that these are similar. So remember, similar figures are the same shape, different size, and their side lengths are proportional, meaning their corresponding sides have to be equivalent ratios. So the first one we're going to look at is AB over DE. So if I look at side AB and DE, does that correspond with side LM and OP? And it does. So this is one of the proportions that proves it similar. So next we will look at side AF over side LQ. So those correspond with each other, and we are going from the bigger shape to the smaller shape. And so we need to make sure that the order doesn't change. Well, our second ratio goes from OP to DE. And while those correspond, the order is flipped, and so this is not going to be a proportion that proves that these are similar. Now we're looking at CD over NO. And then EF over PQ. And those do prove because they're corresponding and they're in the correct order. And then lastly, we have BC over EF. So BC over EF. And then MN over QL. And those do not correspond because QL does not correspond with EF. So this proportion does not prove that those are similar. Right. And the last thing that we want to look at is the quadrilateral JKLM, and it's dilated using a scale factor of 1/4. We are given that quadrilateral JKLM, the original, has a perimeter of 32 units. So let's first graph quadrilateral J prime, K prime, L prime, and M prime, which we can do by finding these coordinates and finding the new values. So point J is at -8, 4. Point K is at -4, 8. Point L is at 8, 8. And point M is at 4, 4. So to find J prime, K prime, L prime, and M prime, we're going to take 1/4 of all of those coordinates. So 1/4 of -8 is -2. And 1/4 of 4 is 1. 1/4 of -4 is -1. And 1/4 of 8 is 2. 1/4 of 8 is 2. So L prime is 2, 2. And then 1/4 of 4 is 1. So we have M prime at the coordinates of 1 and 1. So now we are going to go and graph it. There's J prime. There's K prime. L prime is at 2, 2. And M is going to be at 1, 1, 1. So I know the perimeter of the bigger parallelogram is 32. Well, I just took each of those sides and I took 1/4 of them, meaning that the new perimeter is going to be 1/4 of the original. So perimeter of the new shape would be whatever 32 divided by 4 is, which we know is 8. But now we want to take a look at the area. So I can find area of JKLM. Because I know that to find area of a of a parallelogram, I do base times height. And the length of my base is 12. And my height is 4. 12 times 4 gives me 48. So the area of the original shape is 48 units squared. Well, to find the area of J prime, K prime, L prime, M prime, I can use the same formula. I know it's base times height, but now my base is only 3 units. And my height is only 1. So 3 times 1, and I get an area of 3. Well, that's a lot different than just dividing by the scale factor to find the new perimeter. Because if I divide 48 by 4, I get 12. But I have to divide by 4 again to get 3. And that's because when we do perimeter, we're only worrying about one of the dimensions. So you only would have to multiply by the scale factor one time. Whereas with the area, you're affecting 2 dimensions. So you have to scale it by the scale factor 2 times. So perimeter is just related by scale factor. And area is related by scale factor squared. Thank you.